Okay, so I'm going to be going over projectile motion, some of the key equations that we're going to be using, and then I'll go ahead and move over to the homework problem that you had, okay? So just a quick review of what projectile motion is. It's pretty much the same thing that you've been doing with free-falling objects, except now you're working with things in the x and y components, where before you're only working with y components because things were only falling. So now things are being tossed or falling sideways too, sideways and downward. So you have to make sure you split them up into two components. You cannot do projectile motion into just one in one component because your answers will be totally off. Okay. So key equations that we're going to be using. This is the one that you'll use most frequently, and it'll probably save your life like a million times, is your x of f equals x of I plus b of it plus 1/2 at squared, where your I use f and i's. F is final, I is initial. So your x, so your final position equals your initial position plus your initial velocity times time plus 1/2 acceleration times time squared. Okay. And the second equation we'll be using is your v of f equals v of I plus at. Final velocity equals initial velocity plus acceleration times time. Okay, so there are a total of 5 kinematic equations, but today we'll just be using these two. So those are the ones that I'll be going over and writing down right here. Okay. So in the problem that you asked me about, it was about this guy playing pool. He wanted to see if he beat a world record. So he had to see what his initial velocity was, which was like his shot or something like that. I forgot his shot speed, something like that. Okay. So basically his initial velocity. And the second part of the question asks what the velocity is when the ball hits the ground. So the ball's coming down this way. Right, it's falling off the table this way. So you have two components, right? This is where the ball lands. So that's 5.25. Actually, we'll label that x of f. That's your final x position. X position, that's where it'll be landing. This is your initial position, which is the edge of the table. And then you have your y initial, which is at the top of the table, because that's where it's going to start in the y direction at the top. And then you have your y of f, which is here at the bottom, which is ground, because once the ball falls, the final position of the ball in the y direction will be the ground. So we'll refer to that as 0. So before you try to start solving, I always advise that you write down what is known. So I'm going to write down what is known in my x's. So my x of f equals 5.25 meters, right? That's my final position in the x position. That's my final position in the x component, okay. And then your x initial equals 0 meters. Right here, because this is our origin, so we're going to label that 0 in the x direction. Right here, this is where it might get a little tricky, just because you have to also do velocity in terms of v, in terms of x and y, but you also have to do initial and final. So there's going to be a total of 4 velocities. So your v of x initial equals, you don't know, because that's what you're trying to find. Your v of x final, you also don't know. So right there are 2 velocities. And then your acceleration in the x direction, it is always 0 meters per second squared. And I'll explain this a little more right now. So in your y direction, what do you know? Your y of f is the height. Or actually, your y of f is 0. Sorry, I mixed that up. Your y of f is 0 because it's the ground. This refers to ground. So you're 0 meters off of the ground, so 0. Y initial, now that is the height. That's the difference between your final and where you start. So this is going to be 0.85 meters. Okay, this is the top of the table. Now your V of Y initial, there is no initial, it also doesn't explicitly say it on the homework, but there is no initial velocity in the Y direction. There is an initial velocity in the X direction, because when the guy hits the ball, he's hitting it sideways with the horizontal velocity. There is no vertical velocity. So that is 0. Your V of Y final, we do not know that. Your A in the Y direction is negative 9.8 meters per second squared. So the difference between here and here is because in the Y direction, you will always have an acceleration due to gravity. So whenever we do our equations, we're always labeling A as negative 9.8 because the ball is, or the object is accelerating downwards because gravity is pulling on it. In the X direction, there is no force that's continuing to push the object in the sideways direction, in the horizontal direction. So even though you did have an initial velocity when you threw it, or whatever happened, the ball or the object will continue to travel in the horizontal direction at constant velocity. So there is no other force that's continuing to push it. However, in the Y direction, gravity is continuing to pull it down, therefore it will accelerate and velocity will also be changing. Okay? And we also do not know time. So time is what? So I'm going to start off using my Y's. I'm going to start off using Y because it has one unknown, X has two unknowns. So this is going to be easier to work with, okay? So I'm going to use equation number 1, which is, this is interchangeable, so just because it has X of F equals X of I, you can change that out for Y of F equals Y of I. Okay, so it doesn't have to be X, you can switch it with Y. So Y of F equals Y of I plus V of IT plus 1/2 AT squared. Okay, so my Y final is 0. My Y initial is 0.85 plus my initial velocity is 0. We talked about that right here, T, so that's going to end up being 0 plus 1/2 negative 9.8 T squared. So what I have here, I'm going to bring this over to this side. That's going to be negative 0.85. This is going to be negative 4.9 because you're dividing negative 9.8 by 2, T squared. So I'm going to divide both sides by negative 4.9, negative 4.9. And this is going to be my T squared, right? So T squared equals this. So to make this not squared, I have to square root it. And according to my calculator, I believe this was T equals 0.416 seconds, okay? So I'm going to write this down over here. T equals 0.416 seconds. All right, so now that I know time, that's going to make my life a lot easier. Because now I'm going to use time to figure out my X components. So I'm going to use the same equation, but now I'm going to use it in the X component. So I'm going to have my X of F equals X of I plus V of IT plus 1/2 AT squared. My X of F is 5.25. My X of I is 0 plus V of I. We don't know that yet. We're actually trying to solve for that. T, 0.416 plus 1/2 AT squared. But as we talked about earlier, there is no acceleration in the X direction, so we're going to go ahead and get rid of this. So now we're going to solve for V initial. So I'm going to divide both sides by 0.416. By 0.416. This is going to equal to VI. And I believe this is 12.6 meters per second, which is VI. Okay? Vx. So I'm going to write this over here. Vxi equals 12.6 meters per second. Awesome. So knowing this, I am also going to, so this is actually actually your answer for number 1. Forgot to mention that. This is the shot speed, the initial shot speed, I think it was. And since brake shot speed, got it. And since his velocity was 12.6, and the record velocity was, I think, what did it say? 14.3. 14.3 meters per second was the world record, so obviously he could not beat it. So too bad for him. Going to the second equation, we need to find the speed of the ball hitting the ground. So with this one, it's also a little tricky because now you need to combine x and y directions for a total velocity hitting the ground. So the equation that we're going to be using is v in the x and y direction. We're going to be using square root of v final in the x direction squared plus v final in the y direction squared. Okay, this is all under 1 square root. So we don't know what these two are yet, so we need to solve for them. So I'm going to use this part right here. I'm going to use equation number 2 now. Vf in the y direction equals vi in the y direction plus at. So my v final in the y direction is going to equal to, well, my initial velocity in the y direction was 0, plus my acceleration was negative 9.8, and my time is 0.416. And that is going to equal 0.416. That's going to equal negative 4.08 meters per second. So I'm going to write this over here. So my Vf of y equals negative 4.08 meters per second. Awesome. So here's also the thing. We're going to do the same exact equation, but now in the x direction. So my Vx in the my V final in the x direction equals my V initial in the x direction. I did this backwards. Plus at. There is no acceleration in the x direction, so this goes away. So what that means is Vx final equals Vx initial. So why that is because you have a constant velocity in the x direction. It kind of seems counterintuitive because you're like, okay, but the ball's going to eventually stop. It does, but in the equations that we're going to be using, I think that's a little more complex physics, but there is a constant velocity and we're not calculating for friction and things like that. So initial velocity, final velocity in the x directions are the same. So we know that it's 12.6 meters per second. So B f of x equals 12.6 meters per second. All right, so I'm going to use these two to plug into this equation, and I'll use that over here. So v x plus y equals the square root of 12.6 squared plus negative 4.08 squared. So now if we plug that into our calculators, this is going to be square root of 158.76 plus, it's going to be like 16.64. Yeah, 0.6 or 65, whatever. Plus 158.76. Okay, so it's going to be a total of 175.41. Now we're going to take the square root of that, which is 175.41, which equals to 13.24 meters per second. This is your Vx plus y. So this is your answer for number 2. Okay, so if you have any questions or I didn't really clarify anything for you, if I confused you even more, go ahead and just let me know. and I'll try explaining it to you in a different way. Or if you just kind of need me to go over any more things, just let me know, okay?